yesterday. Notes are going to be important to kind of go back on right here. This next one right here that we're trying to verify right here, which side looks like the more difficult side? Start with the more difficult side, try to get to the easier side. Now we said yesterday, if I can get things in terms of sine and cosine, that's cool. But I'm going to go about this next one a couple different ways and show you something right here, okay? Guys, first of all, when you see stuff to the second power, which identities should almost like be like, oh, I better check those. You remember what they were yesterday? Okay. So on those Pythagorean identities right here, whoops, next page at the top, is there anything that involves a secant squared and a 1?
Yeah.
Okay, didn't we manipulate this second one right here to say secant squared minus what? 1 is what?
Oh, wait. What is here? I'm looking at a secant, but mine doesn't.
Okay. We wrote some extra notes down here, didn't we? Isn't there a secant squared minus 1 in there?
Yeah.
What's secant squared minus 1 equal? Okay, so one thing I could do here, guys, is this. I'm going to do this a couple different ways to show you that there's not really, oh, we don't want more aliens. We want to go to here and say, all right, I'm going to start with this right here. So that top part where it says secant squared minus 1, what can I replace that with, kids?
Example 2? 3?
We're on example 3 right now. And everything's frozen. That's awesome. Awesome.
Oh, okay.
Fun times at the U right now, let me tell you. Okay, so we're right on, what in the world is going on? I swear to God, Ford makes everything anymore.
It's the alien.
It is the aliens. I told you. Okay, so we're right here, right, kids? So what can that secant squared minus 1 be replaced with by one of the Pythagorean identities? So I'm going to call this tangent squared, kids, over secant squared right now. Now, I don't want to put equals anything because I'm trying to say, what we're trying to do, kids, is we're trying to start with the difficult side. We started with this side right here, and we said, you know what? I can say this side is now what? Tangent squared over what? Secant squared. Now let's talk about this, kids.
Yeah.
I'm going to put the thetas on it. I sometimes forget to do that. And if you forget to do that, I'm not too concerned if you do. That's just saying it's a variable there, all right? Now, things to think about here, kids. Okay? Tangent squared, we said things work a lot better for us if we can use what two functions of the 6? Sine and cosine. Is there any way to rewrite tangent here, kids? Okay. All right. I'm going to say from this right here, watch what I do. I'm going to call this tangent squared sine over cosine squared. Is that okay, kids? So it becomes sine squared theta over what? You guys okay with that? That's the tangent part, isn't it? Okay, do you agree with that? Okay, now, listen carefully on this one right here. When you divide by secant squared, isn't that really just like multiplying by 1 over secant squared? Because that would keep secant squared theta in the bottom, wouldn't it? Okay. Okay, so this tangent became what over what, kids?
Sine over cosine.
Okay, now, again, we're kind of on this idea. Well, guys, I know that sine squared over cosine squared is a good thing for us. The thing that maybe we're struggling with is that 1 over secant squared, right? Go look at your reciprocal identities. What would 1 over secant equal? Cosine, right? Okay. So this part right here could just become what now? It's 1 over secant squared, so this part right here could become not 1 over cosine squared, but just
cosine.
Yep, so this is now going to be, wrap it around to here. So it'll be tangent squared, which is the sine squared over cosine squared, right? So this is like Sine squared. Yeah. Over cosine squared. Times what, kids?
Cosine squared.
Yeah, the reciprocal of this, or 1 over secant squared, is the same as cosine squared. Guys, what are the cosine squareds going to do to each other now? Well, okay. So let's see. What do I have to do now?
Nothing, that's your answer.
Nothing. Have I shown how to get that equal to sine squared?
Yep.
Hey, now let me show you something else here. Yeah, hang on a second. Hey, what's your question?
Okay, so it was tangent squared over secant squared.
Yep.
And then I get how we got the sine and the cosine, but what happened to the secant?
Isn't the tangent divided by the secant just like tangent times 1 over secant squared? It's just like saying this. It's just like saying this. What's 9 divided by 3? 3. Isn't that the same as 9 times 1/3?
Yes, I get it.
Okay, so instead of just having, like, this was my secant squared down here, it would be the same as timesing by 1 over secant squared of that in the denominator, right? Okay, now, another way to maybe think about it was this, all right?
What happened to the secant on the top right, the 1 over secant squared?
This?
Turned it into cosine.
Oh no, bottom.
Bottom?
Go down one more.
So
Yeah,
1 over
yeah.
secant, 1 over secant by your reciprocal identities
Yeah.
is equal to a cosine. So if
It
you've got
is?
1 over secant squared, that just became
Cosine.
cosine squared.
Okay. I really need to memorize this.
Yeah. Okay, now let me show you something else here to kind of look for too, guys. Notice in the numerator, what's common in the numerator and denominator here? Okay, the thing that's kind of cool about it is this. If you don't recognize that Pythagorean identity right away, maybe you saw this. Is it possible I could divide secant squared into both of these?
Yeah.
Okay, so guys, real quickly, I'm going to do it a different way here. And I'm going to show you we get to the same spot. If I take secant squared into secant squared, what's one thing divided by the same thing going to be? 1. So that first part would become 1. Do you guys really agree that I can rewrite this as 1 minus 1 over what?
1 over secant squared.
Okay.
Oh,
Well, kids, go look at your 1 over secant again.
that's cosine.
So that's like 1 minus cosine squared, isn't it? No?
1 minus cosine squared equals sine squared.
So from this right here, we go to, this becomes 1 minus cosine squared of theta, doesn't it? But 1 minus cosine squared was one of our important identities that we manipulated yesterday,
Which is
Sine.
which is just what?
Sine squared.
Okay. So guys, it's not so much about solving for a value anymore. It's about doing the work in between to start here and get to the end. You're kind of like starting here, showing the work so that you can get to the what? Finish line. Okay, I'm going to pick on Gracie Rathy. Gracie, can I pick on you? This is Gracie at the start of our race. This is Gracie at the end of the race. This in between is Gracie running the race. And I want to see the running the race part that's going to be the work that you've got to complete. Okay, does that make sense? We know where she's going to start, and we know where she's going to end. We just want to see what?
the right.
The race. Okay? All right. What is 1 minus cosine squared again then?
Sine squared.
Okay. That was kind of nice, wasn't it? That was a lot easier. Now, kids, do we get to the same place each time?
Yep.
Did I do them exactly the same? Did I do them exactly the same way?
No.
No. Okay, and what I would tell you is this. I still think it's important to try and get things in terms of what and what.
Sine and cosine.
Sine and cosine. Use your identities to try to get to terms of sine and cosine. Well, alrighty then. Let's see what we can come up with. Are we on the last page already?
Yeah.
Well, would you? Looky there.
You weren't lying when you said us were trick or treat.
What's that, Caitlin?
You weren't lying when you said not to scare you. This is where trig starts to get tricky.
Was I lying or not lying?
You were not lying.
I don't understand.
Carson, did you hear my joke yesterday?
It's not tricky, it's probably tricky.
We're getting tricky with it.
And it certainly isn't funny. If I
It
lose,
definitely is funny because you just laughed.
if I lose the page that has all of like the identity and little things, I don't think I can.
Okay. All right, let's talk about this one. Okay, okay, let's just talk about this right. First of all, what looks like the most difficult side?
Left.
Okay, so where are we starting the race? Left or right?
Left.
We want to start here and we want to end at what?
1.
1. So we've got to show the work in here. Now guys, I see right up here, I see, ooh, sine of x. That's good, isn't it?
Yeah.
Cosine of x, is that good?
Beautiful.
Okay. The thing that I struggle with is like over cosecant x and over secant of x. But let me show you right here, kids. Isn't the sine of x over cosecant of x like saying, well, this is really the sine of x times, can I write this as 1 over cosecant x?
Yeah.
Okay, are you okay with that first part?
Yep.
Second part, leave the cosine alone. Take that as a, break it up a little bit, right? As a I'm sorry, I got so many co going. Right as a cosine of x times what?
1 over the secant.
Okay. So all I've done is kind of rewrote the way we started that problem, right?
Yeah.
Again, I'd like to get in terms of sine and cosine, if at all possible. How about that 1 over cosecant x? What is that?
I mean, I did that in Spanish the other day.
So this is like sine of x times what, kids?
Sine of x times sine of x.
Remember taking that calculation?
Oh, shoot.
Is 1 over secant by chance cosine?
Yeah.
Yeah.
By chance it is. Okay, so how many sines are you multiplying here, kids?
2.
So we're now down to sine squared of x, aren't we?
Yep.
Plus what?
Plus cosine squared.
Oh,
Oh crap. I did this wrong. Ah.
we're down to sine squared and cosine squared. Anything about that at all?
I thought you
That equals what value?
1.
Now where are we trying to get to?
Wow.
What's my finish line?
Done.
We're done, aren't we? Have I done the work to get to the finish line?
Yeah.
Okay, so I'm going to say this would equal 1 right there, okay? So guys, essentially what you're doing when you're verifying something, I'm saying start out with the side that looks more difficult, okay? Guys, before I wrote equals 1, did I put an equal sign anywhere in that?
Nope.
Okay, don't even put an equal sign, forget this. You're kind of saying, I need to change this so that when in the end I get to what? 1. If you want to do this, say, okay, this is this times this, which becomes, I would maybe bullet it like this. Okay, this was my first step right here. That's what I did, all right? Then this became this step right here, which became this, which finally got us where? To 1, okay? All right? This is the race to start. This is the finish line. This is what we're really trying to make sure we understand. And I'm going to put this in the cloud so we never ever lose it. All right? That's a cool one. I'm going to hang that up above my fireplace.
Unless the aliens steal it.
The aliens might steal that secret, but someday they'll figure out that that's all code for word number 1. Okay?
Wow.
Come on, that was good. That was good.
Good job,
All right. Kids, what questions have you got? I'm sure you're going to run into some. The only thing I'm really going to ask you guys to do is complete a quick quiz for me today. Once that's done, we're... Okay? Dealio?
Yeah, imagine doing
Okay.
that. Okay, I'll start with this.
And by the way, if you're going to prom this weekend, be safe, have fun.